So we have percent return and percent new. It says let percent return be the independent, it's your X, and then percent new be the dependent. So it's definitely going to be one of these. Percent return is your X, it's your independent. So I'm going to copy and paste the data. Control C copies it. I'm going to go to StatCrunch. Control V pastes it. And then I'm going to go to Data, Arrange, Transpose. And then highlight everything. Control A selects it all, and then Compute. And now it is transposed right here into the return and new. So now I can do a scatter plot. Graph scatter plot. We're going to do percent return. So actually it's missing some data. So 74 and 5 should be part of the data. So I'm going to copy this into a new data table. Control C copies it, new data table, paste it, but I'm going to put 74 on top of it, and then 5. And you should double check to make sure that everything is listed. But it looks like it is. So now we go to StatCrunch, and we're going to go to Graph, Scatter Plot. Variable 1 is your X, variable 2 is your Y, and it looks like this. So our answer is this one. Again, with percent return being the independent variable, or your X. For the next problem, use your calculated regression function. So I'm going to go to Stat, Simple Linear, or Regression, Simple Linear, and then variable 1, variable 2, and then Compute. And then here is our scatter plot. And you can see there's 1, 2, 3, 4, 5, 6 above the line. So it's probably this one, plus we need percent return to be at our X. We have 1, 2, 3, 4, 5, 6 above it. For C, the y-intercept indicates that when there are no returning hawks, there will still be, and then we just copy and paste our y-intercept. Our y-intercept's right here. It's the one without the variable. So even when there's 0 hawks, there's still going to be 31.20 when we round this up. The slope indicates that for each percentage increase, the percentage of new hawks decreases. Decreases means the slope is negative, so decreases by this amount. And we'll just leave that as the 5 rounds to 29 up to 30. The correlation coefficient is right here. It's your R, not the R squared, so it's this one. And it wants us to round to 2 decimal places, so that's going to be 74, which indicates it's not positive perfect, that would be 1. Negative perfect would be -1. Somewhat strong or somewhat weak. Okay, so we have to determine if it is significant. You could look at your p-value. Your p-value is 0.0039, so you would reject the null, which means it is significant. So it is, we'll call that somewhat strong because it's significant. Which point has the largest residual? So we go back to StatCrunch, Options, Edit, and let's do, down here we want to save the predicted values, and then I hit Control, and we want residuals. So you want to pick both of them. I'm going to move this column after the last one. So the one that has the largest residual is, this is 4.3, 5.7. So the largest one is this one. So 66,6 has the largest residual. Explain the residual means in the context. The residual means that when the observed return percentage is 66, the observed new percentage will be, it's going to be, if you round this to the nearest whole number, 6 less than. So 6 less than the predicted new. Removing this data point does not have a large effect on the regression line. And I will explain why in a minute. So first, the residual means, so the data says that when you plug in 66, you get out 6. But based on our model, when you plug in 66, you don't get out 6, you actually get out 11.7. The difference between 6 and 11.705 is this. So when you're plugging in 66, the observed new percentage is actually 6 less than, so what you're observing versus what you're predicting. This is what you're observing. So you're observing, let me deselect it, you're observing 6, and you're predicting 11.7, so the observed is actually 6 less than the predicted. And to see if it is an outlier, you're going to take 2 times S. So 2 times S, S is right here, so 2 times 3.670564 gives you 7.34, and it's not above 7.34. So the absolute value of the residual, to be an outlier, the absolute value of the residual has to be greater than 7.34, and it's not. So it's not an outlier, and it's not an influential point. So now we're going to do the same with this. We're looking at yearly wine consumption and death from heart disease. So I'm going to copy this and go to StatCrunch, and I'm going to paste it and transpose it again. So Control V, paste it, and then we go to Data, and then Arrange, Transpose, select all the columns, and then Compute. So the first one should be 2.5 and 221. 2.5 and 221. Good. So then our scatter plot, we're looking at year on the, all these say wine consumption. So wine consumption on the bottom and heart disease on the top. So graph, scatter plot, and we're going to do wine consumption on the bottom and death on the top. And the one that looks most similar to it, but you want to check the points, maybe this one. And then you want to see 0.7. Let's see. 2.5 goes with 221, and 3.9 goes with 167, and 0.7 goes with 300, 9.1 goes with 72, so yes, and then this part we want to do a regression. So stat, regression, simple linear. We're going to use yearly consumption and death from heart disease, and I'm going to just hit Control and then have residuals and predicted values and then compute. Then you can see that there's 1, 2, 3, 4, 5 above the line. So it looks like it's going to be this one. Or this one also, 1. Okay, and how to determine, look at your wine consumption amounts. It goes from 2.5 to 3.9, so it can't be these really high numbers, right? So the wine consumption is going from 2 to 10, basically. So the one that goes from 2 to 10 is this one and this one, and it's not on the line, so it's this one. Part C, we're going to it says the slope indicates that for each additional, so we want to look at what the slope was. The slope is right here. Copy and paste. It's a negative. And we don't actually need to copy the negative sign because it says it will decrease, so that takes care of the negative. Round to 1 decimal place. And the y-intercept is right here, the one without the x. And that would round up to a 1. The correlation coefficient is listed right here. and we want to round to 2 decimal places, so that would be 84. This indicates so to see if it's significant, you could look at your p-value. Your p-value is this, which would reject the null, so it is significant, and I'm going to say fairly significant. It's not very strong, so fairly strong. And which one has the largest residual? You can look at your residuals right here. I'm going to move this one after the last column. So the largest residual is right here, 2.9131. And the residual means that when wine consumption is at 2.9, instead of getting 131, which is the observed is actually 66 less than. So 66 fewer than the predicted. So this is what you are observing. This is what you're predicting. So the observed is 66 less than the predicted. And to see if it's an outlier, you want to see if it is larger, if your residual is larger than 2s. And S is right here, so 2 times 40.308446. So 2 times 40.308446 is 80.612, and it's less than the absolute value of the residual has to be greater than or equal to 80.6 for it to be an outlier, and it's not. It's less than, so it's not an outlier. It does not have a large effect. And to see if it's significant, it's always the same. The row, or the population correlation coefficient, has to be equal to 0 and not equal to 0. The test statistic is listed right next to the p-value, which we looked at this p-value. Here's the test statistic. Round to 2 decimal places, so that makes 31. The p-value was very tiny. If you look at this, the p-value was right here, 0.0026. 0.003, if you round, is less than 0.010. So if the p-value is low, the null must go, so you're going to reject the null, and there is enough evidence to support their claim that there is a linear association between wine consumption and heart